Fermented wood ash from World War II that makes plants grow insanely fast. Food didn't win World War II by accident. It was engineered. While bombs flattened cities and armies burned fuel by the ton, a quieter battle decided who lasted longest. Soil, nutrients, speed of growth, and buried deep inside that story is a forgotten trick so effective it still humiliates modern fertilizers today. Fermented wood ash. Cheap, brutal, and unbelievably fast. Welcome back to the last global war fronts. This isn't just gardening. This is wartime survival science that fed nations when supply lines collapsed. During World War II, fertilizer factories were repurposed for explosives. Nitrogen went to bombs, not farms. Potassium shipments were cut off. Phosphorus was rationed. Yet crops still had to grow. Fast. Failure meant starvation. So governments and farmers turned to what they already had: fire, ash, and fermentation. Wood ash was everywhere. Every stove, every furnace, every burned building produced it. But, raw ash is harsh, too alkaline, too aggressive. Used wrong, it kills plants. Used right, it becomes a growth accelerator. The missing step was fermentation. Here is the core idea. Wood ash is packed with potassium, calcium, magnesium, trace minerals, and carbonates. Potassium alone controls water movement in plants, enzyme activation, and fruit formation. That's not theory. That's plant physiology. In World War II field trials, potassium-deficient soils produced weak stalks and delayed maturity. Once potassium availability increased, growth speed jumped dramatically. Fermentation is what unlocked it. By soaking wood ash in water and letting microbes go to work, the harsh compounds broke down into plant-available forms. Carbonates mellowed. Soluble potassium increased. Microbial byproducts form mild organic acids that buffered pH instead of spiking it. The result was a liquid nutrient solution plants could absorb immediately. This wasn't guesswork. Wartime agricultural bulletins documented faster vegetative growth, thicker stems, deeper leaf colour, and earlier flowering. Crops reached harvest days or even weeks sooner. In a war where timing meant survival, that mattered. Here's what made fermented wood ash special compared to modern fertilizers. Speed. Synthetic fertilizers often push nitrogen first. That gives fast leaves but weak roots and hollow growth. Fermented ash feeds potassium and calcium first. That builds structure. Strong cell walls, better water regulation. Plants don't just grow fast, they grow tough. During World War II, this mattered for more than food. Fibre crops for uniforms, oil crops for machinery, medicinal plants for field hospitals. All depended on mineral balance, not just nitrogen. Fermented ash delivered exactly that. Another overlooked advantage was resilience. Potassium-rich plants tolerate drought, cold, and disease far better. In bombed-out regions where irrigation systems were destroyed, this was honestly a lifesaver. Crops fed with fermented ash didn't collapse under stress. They pushed through. Now let's talk about why this disappeared. After the war, chemical fertilizer companies exploded onto the market. Nitrogen was cheap again. Potassium salts were mined at scale. Liquid fertilizers were easy to sell and standardize. Fermented ash was messy, local, hard to patent. So it faded. Not because it failed, but because it couldn't be monetized the same way. But the biology never stopped working. Modern soil tests confirm what World War II agronomists already knew. Potassium deficiency limits yield long before nitrogen does. Calcium regulates root tips and nutrient uptake. Magnesium drives chlorophyll. Fermented ash delivers all three in a form plants recognize instantly. Used correctly, it does something modern fertilizers rarely achieve. It accelerates growth without softening tissue. That means faster growth without increased pest pressure. That's rare. Timing matters. In wartime manuals, fermented ash was applied during early vegetative growth and again before flowering. Not constantly. Too much potassium late can reduce nitrogen uptake. The old systems were precise even without modern labs. This wasn't backyard folklore. This was national-level emergency agriculture. And here's the part most people miss. Fermentation wasn't just about nutrients, it introduced beneficial microbes. Those microbes colonized the soil and root zone, increasing nutrient cycling long after application. One treatment kept working. That's why reports describe fields waking up days after application. Darker leaves, faster elongation, tighter internodes. These are classic signs of improved potassium-calcium balance, not nitrogen overload. Today, people chase growth with bottled solutions, boosters and stimulants. World War II farmers used fire residue and patience, and they won. This technique didn't just feed civilians, it fed armies. Logistics officers measured food output like ammunition. Faster harvests meant shorter supply chains. Shorter chains meant fewer losses. Fermented wood ash quietly helped decide who could keep fighting. So, when you hear that old methods can't compete with modern science, just remember this. Modern science keeps rediscovering what wartime necessity already proved. Fermented wood ash works because it aligns with plant biology, soil chemistry, and microbial ecology. No hype, no branding, just results. That's the real lesson from World War II. When systems collapse, fundamentals win. If you want more forgotten war-era science that still outperforms modern shortcuts, you're in the right place. Subscribe to The Last Global War Fronts. Share this with someone who still thinks history has nothing left to teach us. And remember, some of the most powerful weapons of World War II were never fired. They were grown.